equations that have rational expressions inside of them involve, the way you would solve them is by rearranging the equation so that you no longer have rational expressions in them. In other words, what we do is, the first thing is we make the problem easier. Let's say we have a fraction and we can multiply it by anything we want. So we'll have a over b. So we can multiply it by anything we want. Let's multiply it by b. So multiplying it by b. Well, what happens then? You can you can multiply it across. Let's go ahead and just do this the long way, just in case, to make it a little bit easier to see. So that's the same thing as a over b times sorry, just a second, b over 1. Okay, all I did here was I said I had this fraction a over b, so I'm going to, and I can multiply it by anything I want, so I'm going to multiply it by the denominator. And when you multiply it by the denominator, remember that when you multiply a fraction by a non-fraction, that non-fraction is the same thing as that over 1. I thought I'd go ahead and put that extra step in there, and that's what this is. So now I can multiply across, so I'll have a times b, and then b times 1 will just give you b. But now we can just cancel out the b's. So now we just simply have left over a. We have, or a over 1, which is just a. The point being that when you multiply this by when you multiply a fraction by its denominator, then what you get is just the numerator back. But so we no longer have a fraction. Let's multiply it instead of by b. Let's multiply it by bc. And this is just kind of a thought experiment, just to see exactly how this type of thing will work out. So instead of multiplying it by b, we're multiplying it by b times c. So then that will be the same thing. I'm going to go ahead and skip this step and go straight into here. So we're going to have abc over b. So now we have something we can cancel, b and ac. Now, of course, ac is something that is fundamentally different from a, but at the same time, there's something. The thing that's really important to notice is that we no longer have a fraction. See, since we had a fraction, we could multiply it by anything we wanted to, so we multiplied it by something that got rid of the fraction. And so if the principle that I'm getting at here is that if a fraction is multiplied by a number that includes its denominator as a factor, and I'm going to write this down because this is something that might be hard to wrap your mind around. If a fraction is multiplied by a number that includes its denominator as a factor, the new number will not be a fraction. I'm sure I'm going to need to put a line break in there. Okay, so if a fraction is multiplied, see, here what we have is this is the fraction that we're talking about here, and we're multiplying it by some number that includes its denominator as a factor. See, b is its denominator, so, and b is included. So that means that the new number will not be a fraction. This over here will not be a fraction. So that's pretty important to understand whenever we are dealing with equations that have rational expressions. Let's look at a very simple equation involving fractions. So let's say we have a over b plus c over b equals 1. So a over b plus c over b equals 1. The goal here right now, I'm not talking about solving it. I just want to how can I rewrite this such that it has no fractions left over. It's just a simple equation. Well, we can multiply both sides of the equations by b. Remember that if you have some equation, this is just off to the side, if you have that a equals b, and this is not the same a as over here, I'm just saying this is an arbitrary assignment that I'm just trying to demonstrate the point. And so then we can if we can multiply both sides of the equations, oops, that's not a, by some other number. So if we have an equation, we can multiply both sides of the equation by any number, which means that, if we have 4 equals 4, or let's make it even more simple. Let's make it 4 equals 2 plus 2. By more simple, what I mean is that something that's more applicable, easier to see what I mean. So we can multiply both sides of this equation by, say, 3. So we'll have 3 times 4 equals 3, 2 plus 2. And then we can, so this would be, you can distribute this out, and we'll have 3 times 2 plus 3 times 2. And you have 3 times 4. So this turns out to be 12. 3 times 4 is 12. That does not look like a 2 at all, does it? And then 3 times 2 equals 6, plus 3 times 2 equals 6, so 6 plus 6 is 12. The point that I'm making is just kind of an aside, and I probably spent too much time on it, but when you have two different, when you have an equation, you can multiply both sides of it by some number, or by anything for that matter, by number or variable is what I mean, by either number or variable. That came out more weird than I meant for it to be. So that means that we can multiply both sides of the equation by b if we wanted to. Remember up here, we said if we want to multiply by anything we want to get rid of a fraction, we can multiply by the denominator. So we can do the same thing here. We can multiply both sides of this by b. We could actually combine these fractions if we wanted to, but we don't need to. And in later situations, we'll find that it's actually harder to take the time to add the fractions together. So let's multiply both sides of the equation by b. So this b will distribute to the a over b, and so we'll have, I'll go ahead and write an intermediate step here, but hopefully it makes sense already. Oops, that's not 11, just 1. So you distribute the b, and this step right here is a step that could probably be skipped pretty easily, and then you can cancel out these b's, cancel out these b's. Then there's this 1 which we can just ignore because it's 1. 1 times b is just going to be b. So we can rewrite this as a plus c equals b. So now we had, here I'm going to clear this off just so you can see it. We had a over b plus c over b equals 1, and we multiplied both sides of the equation by b, and we got a simpler equation, a plus c equals b. This is easier to understand what we're doing. So that's the point of what we do with when we have equations with rational expressions. Now let's do something just a little bit more complicated. So if we have 1 over x plus 3 halves equals 3 over x. So we want to multiply both sides of the equation by something that will make this, that will get rid of all fractions. The entire point of this is that we need something that multiplies, that will get rid of all these fractions. So we multiply it by the lowest common denominator. Remember that we had the videos previously on how to find lowest common denominator. We find the lowest common denominator of all 3 of these. So the LCD of this will have it'll have x as a factor, and it'll have 2 as a factor. How many x's will it have? Well, there's at most 1 x's. There's 1 x here and 1 x here. None here, so we'll just have 1 x. It'll have 1 2 because there's at most 1 2. So that I'll just rewrite this as 2x. So we can multiply all terms by the lowest common denominator, because the lowest common denominator will include all denominators as a factor of it. So that's why it's called a common denominator, because it includes all of the denominators. So let's go ahead and rewrite this equation and multiply it, both sides of the equation, by the LCD. So this will take just a little bit to type out. Okay, so I'm multiplying the left side by that. Oh, I forgot to multiply. Okay, so I'm multiplying both sides of the equations by both sides of the equation by the LCD of all three of these. So what that'll do in the end, so this what that will do in the end is get rid of all the fractions, and we can see that in action. So let's go ahead and distribute this 2x to this and to this, and there's not really any distribution needed, but I'll go ahead and put it here. So that means we'll have 2x 2x times 1 over x, which will give us just 2x over x. If that's confusing, go ahead and you can work it out so you can see how that works out. So then we have plus 3 times 2x over 2. So this is just 3 times 2x over 2. I could multiply this together to make 6, but it's not really necessary because I'm about to cancel that 2 anyway. Then, of course, we have 3 times 2x over x. So these x's will cancel, these 2's will cancel, and these x's will cancel. So what we have in the end is everything that's left over. So I'll go ahead and rewrite that. Everything that's left over. So that's going to be 2 plus 3x equals 6, because it's 3 times 2 is going to give us 6. So I canceled out everything that was unnecessary, and I was left with an expression and an equation that no longer has any fractions. So now we can deal with this pretty easily. So I can go ahead and subtract 2 from both sides. So we'll have 3x equals 4, and then we can divide both sides by 3 and get x equals 4/3. So this ends up being the final answer, and we can check that by plugging x into both sides of the equation. I'm going to go ahead and do that. It doesn't hurt to do that, so it shouldn't take too long. So we'll have 1 over 4/3 plus 3/2. So this 1 over 4/3, remember that this means, here's an aside for the aside, this means the same thing as 1 divided by 4/3, which is 1 times 3/4, and that's just going to be 3/4. So we have 3/4 plus 3/2. And we need to change the common denominator, so we'll have 3/4 plus 6 over 4. So that'll give us 9 over 4. So now we need to check this one right here, see if it turns out the same way. So 9 over 4 is the left side. Now we need to check to see if the right side works out the same way. That's really bad handwriting. Sorry, I'm going kind of fast. So 3 over 4/3. 4 over 3. And using this same kind of work, you can work it out if you want to. It will be 3 times 3 over 4, which will be 9 over 4, which turns out to be the same. So now I know that 4/3 is right. And it's very important in this type of problem to check your answers, because see, we have an x in the denominator here. It's possible that in the answer you get, you will end up dividing by 0 if you use that, and you can't divide by 0. Okay, so that's we're going to have some more examples later on, but this is an example of this is a quick example, and I'm going to go ahead and have a sort of a checklist that you can do. So to solve equations that have rational expressions, the first thing you do is you find the lowest common denominator of all the terms. That was the first thing we did. It turned out to be 2x. I didn't type it out, but that's what it turned out to be. Multiply both sides of the equation by the LCD, then simplify. That's what we did here. And this was the simplified form. This was multiplying it out. Ooh, this was this part that I attempted to underline. This was multiplying it out, and this was part of the simplification. This was the final simplification. And then now we have a simple equation that we can solve, and we ended up with 4/3. Something that I forgot to write down, but I'm going to definitely do it right now, because this is actually essential. The reason why it's essential is because, like I said, you could end up with a solution that actually does not work. So you want to double check it to make sure that it works out correctly. Alright, I will see you in the example video next.